For this problem, we're given a rational function. First, we'll find its domain, and then we'll use several steps in order to graph the function. So we have f of x is equal to 1 over the quantity x plus 3 squared. So the first thing we want to do is find out what is the domain of this rational function. Well, we look at the denominator and we set it equal to 0. So we have x plus 3 quantity squared is equal to 0. If we take the square root of both sides of this equation, we just get x plus 3 is equal to 0, or simply x is equal to negative 3. So x equals negative 3 is the value that makes the denominator 0. Therefore, we can say that the domain of this rational function is that x is not equal to negative 3. We could write it in set notation if we liked, or interval notation, but it's important just to note that x cannot be equal to negative 3. Now, let's go through the steps of how we'll graph this rational function. The first thing it's always a good idea to do is to determine if there's any symmetry. We determine symmetry by looking at f of negative x. Let's look at it in this case. It's 1 over the quantity negative x plus 3 squared. Now there's three possibilities. The first possibility that f of negative x is exactly f of x, our original function. If that were the case, this would be an even function and it would be symmetric to the y-axis. That's not the case here, because if we distribute this negative x plus 3, multiply it by negative x plus 3, in the denominator it's not the same thing as x plus 3 quantity squared. The second possibility is that f of negative x is exactly the opposite of the original function. That's not the case here either. But if it were the opposite, it would be an odd function and it would be symmetric with respect to the origin. So in this case, there's no symmetry, and we'll just write that there is none. Now let's move on to step 2. In step 2, we want to find the y-intercept. We find the y-intercept by letting x equal 0. So that's just the same as finding f of 0, which in this case is 1 over the quantity 0 plus 3 squared, which gives us 1/9. So we know, first of all, that we have a y-intercept of 1/9. So let's go ahead and plot 1/9 close to the x-axis on the y-axis. Next, we'll move on to step 3. We want to find any x-intercepts. We do that by letting y equal 0. When we let y equal 0, or f of x equals 0, that simply means we set 0 equal to the numerator of our rational expression. Our numerator is 1. Well, 0 is not equal to 1. That's a false statement. So what this tells us is there are no x-intercepts for this graph. Let's move on to step 4. I'm going to use a little abbreviation here. We want to find any vertical asymptotes, so I put VA. Well, we set the denominator equal to 0 and solve for that. We already did that up here in red. We set the denominator equal to 0, we solved for it, and we got x equals negative 3. So we do have a vertical asymptote of x equals negative 3. That means our graph will not cross this vertical asymptote of negative 3. Next, in step 5, let's look for any horizontal asymptotes. In order to find a horizontal asymptote, we're really comparing the degree of the numerator with the degree of the denominator. Anytime we have the degree of the numerator being less than the degree of the denominator, as we do in this case, we have a horizontal asymptote, which is the line y equals 0. Notice in our function, the degree of the numerator is 0 because it's a constant. The degree of the denominator is 2. Since 0 is less than 2, we have the horizontal asymptote y equals 0. Now, our last step, step 6, is to plot some additional points. Before I plot any additional points, I'm going to start the sketch of the graph. We've already plotted our y-intercept. We know we have a vertical asymptote of x equals -3. So let's draw that in here, crossing through -3 on the x-axis. And we have a horizontal asymptote of y equals 0, which is just the x-axis, so I'll extend it with a dotted line so we know that's a horizontal asymptote. Now the question is, how do we finish our sketch here? What we need to do is we need to plot points between each vertical asymptote and each x-intercept. Well, we only have one vertical asymptote here and we have no x-intercepts. So we'll simply pick a point to the left of our vertical asymptote and a point to the right of the vertical asymptote. And we'll do that in a little chart down here. We have f and we have our function. We have x and we have our function f of x. So for x, let's pick a value to the left of our vertical asymptote. Since our vertical asymptote is at -3, let's choose the value -4 for x. If we substitute -4 into our original function, in the denominator we have -4 plus 3, which is -1. When we square that, it's just 1. Since 1 over 1 is 1, the function value is 1. So therefore we can say -4, 1 is a point on our graph. Let's pick one to the right of -3. Why don't we pick -2 for x? If we substitute -2 into our original function, we again end up with 1 over 1, which gives us a value of 1. So let's plot -2, 1. Now we're ready to finish our sketch. Since we know that anytime we have an asymptote, the graph will tend toward the asymptote, we can sketch our rational function like this, going through any intercepts that we've found. And here's a graph of our function f.